Forces and braking. Now, if you've noticed the car in the background image for this film, then you'll notice that somebody didn't brake in time. That was taken in the school car park. Now, just a reminder then about steady speed. When the speed is steady, the resistive forces, the forces holding you back, this is mostly air resistance, balance the driving force. The driving force is the push from the engine. So the resultant force is therefore zero. That's when you're travelling at a steady speed. But when an object's accelerating, the resultant force is not zero. So the vehicle will accelerate or decelerate. So for example, when the resistive force is greater than the driving force, the vehicle slows down. And when the driving force is greater than the resistive force, the vehicle speeds up. Now, it's important to remember that when a vehicle speeds up, the resistive force increases as well as the driving force, and we'll come into this a bit later on in more detail, but the faster you go, the greater the air resistance, because the air particles are hitting you more frequently and more force. So for the vehicle to accelerate, the driving force increases by more than the resistive force. Now let's talk about stopping distances then. How much distance is needed to stop a vehicle? So this depends upon two things. It depends upon the distance covered while the driver reacts. This is called the thinking distance, not the thinking time and not the reaction time. It's the thinking distance, the distance covered while the driver reacts. And it also depends upon the distance travelled while the vehicle is braking. That's called the braking distance. Now your answer should always be in the form of the distances travelled, not the time taken. So we never ever refer to the thinking time in any of these questions. It's always the thinking distance, the distance travelled while the driver reacts. And the braking force needed to stop the vehicle within a certain distance depends upon both the initial speed of the vehicle and upon its mass. Remember, force, mass, acceleration, and remember acceleration can be slowing down as well as speeding up. So the slowing down bit, the braking force, depends upon the initial speed and the vehicle's mass. Now the braking distance can be affected by various external factors. It can be affected by poor weather or poor road conditions. For example, if the roads are really wet or really icy. Can be affected by poor brakes and by worn tyres. Now what you mustn't do is just give a vague answer about the condition of the car. So you have to actually give examples about something that really does affect the braking distance. So you can only really talk about the brakes or the tyres. Now the thinking distance, not the thinking time, the thinking distance can be affected by the driver's tiredness, whether the driver has used drugs or alcohol, or whether the driver is distracted by things like mobile phones. Now, you need to remember the concept that work is done when a vehicle is braking, and this is work in a physics sense. This is when energy is transferred. Now when the brakes are applied, work is done by the friction between the brakes and the wheel. And the result of that is that the kinetic energy of the vehicle is reduced by the friction. Now remember this beautiful phrase, you'll use this a lot. Energy is transferred when work is done. So the kinetic energy of the vehicle is transferred to the brakes as heat. Now this is visualised by this lovely blue car. The car's travelling from left to right, so the driving force is pushing it from left to right. But working against the driving force is the drag force. That's air resistance. And then when the brakes are applied, that's a larger force. We now have a resultant force. And so the vehicle slows down, but the kinetic energy of the vehicle is transferred as heat. So have a little test now on forces and braking. Pause the video and see how you get on with these answers.